So G has the possibility, since G has the possibility to have them, and since say G reacts with sulfuric acid, that means there's a high chance that G contains actually amine. Let's see. We don't know so far, but let's try. Let's say we do have, like, whatever it is, there should be an amine. Then there is this carbon CH2, let's say. Let's try this one. This is like, let's try with this part. Okay, first, if this is like, if that is here, that means CH3, that should be our first concern. If this is present, then that's completely good to go. And like, why am I giving CH2, CH2? Because that's more generic. Like, otherwise, it couldn't be like we couldn't able to like fulfill the structures. Like, usually, like, try to fulfill like whichever requirements are not stated. Let's say in this case we have 4 carbons, so nothing is mentioned about those 4 carbons. That means it will be much more neutral. Like this 4 carbon, like this 3, like 2 to 3 carbon should be neutral. So in this case, let's say C2, CH2, 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 3 CH2s are there, and 1 more carbon is there to fulfill 4 carbon. And if this is the case, let's see how many. This is CH3. That means 1 more carbon I have given, like extra carbon I have given. So that means there should be actually 3 carbon, then CO, CH3. Yeah. Now let's see how many carbons. 4 carbons, 3 hydrogen, 2, 3, 2. That means 5, 6, 7, 8, 9. That means 9 hydrogen. But we need 11 hydrogens. That means this is not possible. So let's see if then this works or not. I'm not sure. Let's see actually. If this is OH, that is H, and this is CH3, does it fulfill? 4 carbons still. 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 hydrogen, yes, and 1 oxygen. Nice. So this is G actually. So this is G. G is done. We're done with G. Let's go to the next one, which is in this case H. We had more information about G in this case. If we could say we had also more information about F, but it said F was neutral. That means F actually didn't react with H2SO4 and NaOH. That means neither amine was there, neither some acidic substance was there. That means F was neither acidic nor alkaline or nor basic. That means F couldn't react, but we need more information about F. So far we have more, like the next informations we have is about H, which says it needs sodium hydroxide. That means it reacts with sodium hydroxide. So H is this one. We have C4H6O3. If it reacts with an alkali, that means there could be a carboxylic acid present. That's just an assumption. That means and carboxylic acid could be present there. At the same time, it also reacts with to form iodoformation reaction. Remember, carboxylic acid does not undergo iodoformation reaction. In order to undergo iodoformation reaction, either of these 2 conditions needs to be fulfilled. Okay. From these 2 structure, either of them needs to be fulfilled. Let's see. Let's say we have a carboxylic acid and one of this structure. So how many H had C4H6O3? Okay. So we have a carboxylic acid, let's say. Carboxylic acid is there. Then we have C double bond O CH3 group. Our initial assumption should be this one. Okay, our first circuit should be this one. If that's not the case, then we will go to this one. Okay, in order to have this iodoformation reaction, our first target should be making the molecule to have this one. If it can't have, then the possibility is it can have this one. Okay, because iodoformation reaction are basically only for aldehydes or ketone, but alcohol can also participate in the reaction. Now from there we have CH2 and one more CH2. So in this case, let's see if it fulfills the requirement or not. Iodoformation reaction part and reaction with sodium hydroxide part. Now, how many carbons we have? 1, 2, 3, 4, 5. 5 carbons, but we need 4 carbons. That means we have an extra CH2 here. So this should be actually in this way. Yes, C, 1, 2, 3, 4, 4 carbons there. 6 hydrogen, that's C. 1, 2, 3, 4, 5, 6. Yeah, 6 hydrogen and 3 oxygen. So actually this is the case. So this is our H. We got H as well. Now let's see. What else do we have? They are saying we can heat with dilute acid to get that. Oh, remember? Heat with dilute acid. The previous example we did, the first one. I mean, the first molecule we found, boil with H3O plus, hydroxonium ion. Same thing. Heating with dilute acid, that means it contains H plus. That means this is a hydrolysis reaction, and since there's no, this shouldn't have, like this can't have any acid, also this cannot have any basic characteristic. What possibility is there that this will react? Amide linkage. Ester cannot have here, like we cannot have ester here because in that case, like there can't be this. Okay, let's see if ester was there, but we cannot have, yeah, we cannot have ester here because over here in this molecule in G, we didn't have any alcohol, or did we? Oh yes, we have an alcohol. And over here we have a carboxylic acid. So let's see if carboxylic acid could be, like ester could be formed or not. Let's see. We have this H, C, CH3, CH2. Let's for simplicity, let's make it 4NH2. From here, we have O, and there's this carboxylic acid. I mean, this part now. So CH2, CO, CH3. Let's see if it works or not. How many oxygen do we have? There's 3 oxygen. Okay, that's fine. 3 oxygen. How many carbons do we have? 1, 2, 3, 4, 5, 6, 7. 7 carbons we have. 1, 2, 3, 4, 5, 6, 7, 8. Oh, sorry. Yeah, 8 carbons we have. So 8 carbons we have. This is the molecule we're talking about. So 8 carbons there. Then we have hydrogen. How many? 3 here. 4, 2, 8 here. 3 plus 8 is 11, 19. Sorry, 3 plus 8 is 11. 11 plus 2 is 13, 14, 15, 16, 17, 18, 19. This we should have 15 hydrogen. Am I missing out? 4 to 8, 19, 11, 12, 13, 14, 15, 16, 17, 19. So this cannot be the case. Hydrogen is more here. Nitrogen is fine, oxygen number was fine, but hydrogen is more. Let's try amide because that's the one more possibility. If ester is not possible, amide is the other way. Let's see. So if we have OH here, CH, CH3, we have, let's say, CH2, 4, and nitrogen, hydrogen, C. I guess that could be a case. This could be possible. Because 11 plus 6 hydrogen. But forming amide, 2 hydrogen goes. Like G has 11 hydrogen, H has 6 hydrogen. So 11 plus 6 is how many? 17. And when amide is formed, the amine loses 1 hydrogen and carboxylic acid loses 1 hydrogen. That means minus 2 hydrogen, 15. So yes, this could be a possibility. There is the oxygen there for the carboxylic acid part. And CH2, C double bond O, CH3. Let's see now. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon. Yes, 8 carbon. Fine, 8 carbon is there. Hydrogen should be 15. 3, 4, 5. 4 2s are 8. So 8 plus 5 is 13, 14, 15. Wait. 3, 4, 5. What am I missing out here? Am I missing out something? We should have 15, 13, 15, 13, 14, 15, 16, 17, 18, 19. Why am I getting more? Oh, what is happening? Let's see. CH24. There was CH2 group there. CH3, 3. I have there 6. There we have 5. How many do we have here? 3, 4, 5. Oh, this shouldn't be CH2 4. This is CH2 2. That's why. Oh my god. This is 2. I made a mistake previously. So 2 carbon, 2, 3, 4, 5, 6, 7, 8. 8 carbon was there. 2 hydrogen. 2 to the 4. 4 hydrogen. 2 plus 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is possible. Yeah, this is possible. And what about this one? 3 hydrogen, 3, 4, 5, 6, 7, 8, 9, 9, 10, 11, 12, 13, 14, 15. Both having 15. Now that's an issue. That's an issue. We have C8, H15, NO3. In both the cases, it satisfies this. What information do we have? Oh, yeah, forgot. Or is it? Yeah, we have 3 hydrogen there. 3 hydrogens are there. So, oh yes, remember, this was the information I was missing. F is neutral. In which of the situation F is neutral? That's why they also mentioned F is neutral. Yes, that makes sense. See, if this was the case, if ester was formed, we did have phenylamine, sorry, we did have amine there. And amine is what? It is basic. It should react with acid, but they said it should be neutral. So amide is neutral itself. And we don't have any more carboxylic acid or amine group. That means this is the condition. This is actually F. Got it? So this should be F. F couldn't be this ester, like this ester linkage couldn't be there because amine would be there. And we did apply like sodium hydroxide and carboxylic acid, like sulfuric acid there. So that amine would be reacting with carboxylic, like I mean H2SO4. But they said F to F is neutral, so F should be that, like our amide linkage. The last thing we're left with is J. Now, what could be J? There's no information given about J, except for that it undergoes iodoformation reaction. Now they're saying H and G could be formed from J, like both H and G could be formed from J. Now, then what could be J? Let's see. J, from J to there, J to here. That means in one of the situation, nitrogen is disappearing. It could be that, remember, when this nitrogen disappears, at first, let's see, J should contain, from J to H, isn't it? J should contain any of this group. H had what? H had the this group. H was this one, and H had this group. So if H had that group, does it make sense? Let's see. If J also had this group, this is CH2. And what I'm thinking of is, here we have nitrogen, here we don't have nitrogen. Remember about nitrile compounds, I mean the cyanide CN group, when you apply when you make it to undergo hydrolysis reaction, what happens? Acidic hydrolysis causes the nitrogen to disappear. So if that's the case, then this should be the situation, isn't it? How many hydrogen do we have here? So carbon is 1, 2, 3, 4, 4 carbon. Hydrogen 3, 4, 5. 5 hydrogen, nitrogen, and oxygen. Okay, that makes sense. If we do hydrolysis over here, H plus, then this one goes and forms COOH. Does that make sense? Yes, that is actually formed here. And if we didn't do that, rather, they say that we, like, how can we form G from here? G was NH2. That means CN. That means if reduction is done here, that means reduction. What was the condition for reduction? Let's see. Remember, this is number 2 is H plus reflux, we can say. hydrolysis is happening. Our reductions informations were LiAlH4 or NaBH4. Yeah, LiAlH4 in dry ether. So either of them would work, or this one or this one in dry ether. So LiAlH4 would be much preferable, but NaBH4 would also work. So LiAlH4 in dry ether would cause this one to form actually CH2 NH2. So this is actually reduction reaction happening. Okay. So our J is actually this molecule. Why did it pause there? Yeah, this is our J. Okay. So this should be our J. Got it? If you didn't understand, rewind the videos, try to see it again and again. Trust me, rewatch the videos. Go through the solving, go through the workflows again and again. It will make things easier for you. Okay. Now, doing our last reaction of today. Let's see. Our last example should. Oh, before that, we forgot to actually form this one. Oh no, we did form. That was the amide part. Yeah, we did form that one. Okay. Now our example, the last example should be, we have curry cumin. I'll give this as an example, like homework for you. See, don't even try it yourself. See all the notes possible. Just don't go to like you won't actually able to find the mark scheme because these are like selective questions from the question paper, but still like try to do it by yourself. It's completely fine if you can't, but it's mandatory for you to at least try. Hot, concentrated, acidified KNNO. Okay. What did I put? Okay. MnO4. We have here a product here. This is, let's say, A. This A is given as C5H4O6, and they say this is 1 mole, like 1 mole being formed. And here we have, let's say, this is compound B, which is C5H8O6. Over here we have this product being formed, which is CO2H, and we have OCH. Wait, this is CH3, OCH3, and we have here OH. Remember, this is not alcohol, this is phenol. And what else do we have? We have C here, which is C5H6N2O2, which is formed when we, let's say the reactant is CH2, CHO, CHO. Remember, this is aldehyde group. CHO means aldehyde, that means this group. Okay. This is written as CHO. Now, if we apply HCN plus K, it could be KCN or it could be NaCN. Either is correct because we are using catalyst. So NaCN is given in my question. So let it be NaCN. And here we have, this is from 2 mole. Okay, this one, this product, here it is 2 mole. 2 mole given. 2 mole from where? Like after this is reacted, this is from 2 mole and this is 1 mole being formed. Okay, that's what it meant. Now, this question, or from where it is being formed, is that formula is given. Let's say this is D. That formula is C9H10O3. Conditions were, the first condition, I2 plus OH minus. Okay. Second condition was given as H plus aqueous. This is at first alkaline condition, then acidic condition is given. Okay. Remember, when alkaline condition is given first, a salt is formed, then when we acidify it, the acid regenerates. Okay, use this materials and all the notes possible. Try to solve this. It's completely fine if you can't, but try it by yourself. Okay, take care. Allah Hafiz.